In this video, I will talk about the waveform of Godunov's method. Let me just review what we have done until now. We have a Godunov's method. The Godunov's method is written as like this. For example, we have Qn I plus 1 half or minus 1 half Qn I minus 1 half 1 over delta x xi minus 1 half to xi plus 1 half, and there is a value of q, qxt and dx. So this was the average value of a quantity q. What Godunov said that you can replace this q with q tilde. It can be a constant. It can be a, for example, piecewise polynomial or polynomial. Mostly it is piecewise since you have points and you need only different polynomial in each subintervals. So this is the idea of Godunov's method for variable. Similarly, if I talk about the Godunov's flux, what is Godunov's flux means? We have, for example, flux defines on Ni minus 1 half, and we have average, the flux average on the cell phase I minus 1 half, and then we have Tn to Tn plus 1, and there is a flux Fq which depends on the values of Qni minus 1, Qni dt. This is the numerical flux that we usually define in finite volume method. Suppose that we take a Godunov's flux. Godunov flux means that you need to replace this Q with some other quantity, some constant quantity or some Q static. So when it is Q static, then we have a numerical flux. And this is defined at cell I minus 1 half. So this was all about the review of Godunov's method. Now we want to write the wave propagation form. Usually the wave propagation form arises when we have a system of equation. So if we have only one equation, suppose we have this one equation, we have one equation, partial q by partial t plus partial by partial x u bar q is equal to 0. So there is only one wave, so we have only one wave over here. Now suppose that if we have a vector partial by partial x, and this is also a vector, it should be q, it should be q vector is equal to 0. Then here this is the vector form. In vector form we have more than one waves. So in that case we need to write our formula accordingly. So the wave propagation form is to write our solution in terms of W, that we will talk about. Suppose that we have a cell number I, then we have I plus 1. If this is, for example, I, Then this is cell I minus 1/2 and I plus 1/2, and this is I plus 3 by 2, 3 by 2. Okay. I minus 1/2. This is I plus 1. Everything enters into this finite volume from the cell face over here. It should be I plus 1/2. Suppose that there are three waves, lambda 1, lambda 2, and lambda 3. Lambda 1 is less than 0. Lambda 2 is less than lambda 3. So you can see that we have two waves over here, two waves which has speed positive, positive speed with positive speed, positive speed. Another one is lambda 1, which is less than 0. It has a negative speed, negative speed. The two waves are moving from left to right. These two waves are moving from left to right. And this wave is moving from right to left. So we need to write the waveform of Godunov's method. Suppose that this is the uh, cell I minus 1/2, and we have wave number 3, which has a slope positive, that is W3 I minus 1/2. Then we have another wave that has slope a bit larger, since W3 has some slope, W2 I minus 1/2, and there is another wave, and that wave has a negative slope, W1 I minus 1/2. Okay. Then there is a discontinuity, that is a discontinuity, and that discontinuity moves with some speed, lambda 2 delta t. It covers some distance. So we know that to find a discontinuity, we should have, for I minus 1, if you want to identify a discontinuity, the discontinuity is at I minus 1/2, and there is left point I, and there is right point I plus, I'm sorry, this is I minus 1, and this is only I. Okay. So there are two cells involved for the value of I minus 1/2. One is I minus 1, and another one is I at nth level I. And there is a discontinuity at this place if we have a Riemann problem. If we have a Riemann problem. Okay. To identify this discontinuity, what we do, we take a difference. For example, we take a difference of Qni minus 1. When we take this difference, then we get the wave. Actually, what your wave is discontinuity. This is your discontinuity, which is also a wave. This continuous wave is traveling. So we can identify the discontinuity. Remember that the discontinuity by taking a difference of these two values. Okay, so you can identify the discontinuity by taking a difference of Qi minus 1. Suppose that if you are interested in I plus 1/2, this I plus 1/2, then there is a value qi plus 1 that is involved in the phase I plus 1/2, and there is qi. So in that case, you take a difference of qi plus 1 and qi. Then you identify the discontinuity at I plus 1/2. This discontinuity only arises when we have a discontinuous solution. Discontinuous, you should say, initial guess. For example, we have, u left and u right if x is less than 0 and if x is greater than 0. And if you draw that, then you get, for example, u left, and then we have u right, and there is a discontinuity at x is equal to 0. So this discontinuity actually travel from left to right or right to left discontinuity. After some time, this will move over here, then it will move over here, so on and so forth. So we are talking about the discontinuity at this I minus 1/2 and I plus 1/2. So I repeat this again and again, so you become used to of this wave. Whenever I use the term wave, it means that the discontinuity is traveling from left to right. So qi minus 1 will be equal to, we earlier saw that the waves can be written as by the alpha and multiply with the eigenvector r that we already saw in our previous video. Since there can be many waves, so for many waves we use summation, and we call the index p for the wave, and the wave is from 1 to m. This is p, and we also have rp. And where we are calculating the discontinuity, we calculate the discontinuity at I minus 1/2, so there should be I minus 1/2. So we can write this I minus 1/2. So we must have I minus 1/2 values of alpha on this I minus 1/2. Okay. All right. If we just talk about the W2, suppose we talk about the W2. For the wave W2, we have W2 I minus 1/2 is equal to alpha 2 I minus 1/2 R2. Here R stands for the eigenvector and 2 stands for the wave number 2. And here alpha is a unknown and 2 is the wave, and I minus 1/2 means that we find out this alpha at I minus 1/2. And this quantity on the right hand side was equal to W2 I minus 1/2. When we use such value in the numerical method, suppose we have Qn plus 1 I is equal to Qni minus delta T by delta X, and we have, for example, the flux Fn I plus 1/2 minus Fn I minus 1/2. And suppose we have upwind method. In upwind method, all the information is traveling from left to right if u bar is greater than 0. For upwind method, we have Fn I plus 1/2 is equal to u bar q I. So we have Qn plus 1 I is equal to Qni minus u bar delta T by delta X, and we have Qni minus, and it should be at I plus 1/2. What should be value of I plus 1/2? Yes, it should be I. Qi minus at I minus 1 half, we have qi minus 1. As we saw that this qi minus qi minus 1 is equal to the alpha and r, and this is equal to w pi minus 1 by 2. So we can write it as p 1 to m wp I minus 1 by 2. So you can see this is the difference, and here we also have a difference. So we put the value of qi minus 1 in this value over here in the numerical method. Then we get qn plus 1i qni minus u bar delta t by delta x, and it should be qni. And we call this as wp is equal to 1 to m wp, maybe for only wave 2. Suppose if I talk about only wave 2, w2 I minus 1 by 2. And remember that if you are talking about if you are talking about 3 waves, it means that then it should be the speed of wave number 2, and then we have the speed of wave number 2, and this becomes the speed of wave number 2. So we have qni minus plus, and this is lambda minus lambda 2 delta t by delta x w2 I minus 1 half. That's how you can modify the numerical method for your wave number 2. Okay, so this was the example of only one example where we had wave number 1 and wave number 2. Let me just generalize for the all 3 waves. We need to look at the formula, general formula for all the waves. So that formula becomes qn plus 1i qni minus lambda 2 delta t by delta x w2 I minus 1 half minus lambda 3 delta t by delta x w3 I minus 1 half minus lambda 1 delta t by delta x w1 I plus 1 half. Okay, this was the formula for numerical method. What is this formula tells us? Here in this formula we accommodated all the waves that are coming from left and also from right. Here we have the wave for I minus 1 half. On the I minus 1 half, there are 2 waves which has a positive slope. So they are moving from left to right. And then we also have one wave that is moving from right to left, which has slope less than 0. Remember that this is the another description. We can also draw the wave in xt plane as well. Xt. From xt plane, you will know that the wave which has positive slope are moving from left to right, and the waves that are moving from right to left that has negative slope. Let me just remind you, for example, we have partial q by partial t, u bar partial q by partial x is equal to 0. In this case, u bar is greater than 0. If this u bar is greater than 0, you know that the characteristic is the slope is positive. So all the slopes will look like this when the wave travels from left to right, so on. So we just, this was an example of only one wave, that was wave number 2. We want to generalize it. We want to include the wave number 1, wave number 2, and wave number 3 in this only one formula, so that the each, and remember that this q will not be a scalar anymore. It could have 3 values. There are 3 values, so there will be a 3 answers. Now, if we just look at this formula, we already saw that for wave number 2, all the information is coming from wave number 2. And then we also have information from wave number 3. Then we have, for example, this value I plus 1 half. Let me just explain this for you. We have I minus 1 half. Then we have I plus 1 half. Two waves are traveling from left to right, and these are lambda 2 and lambda 3 greater than 0. The slope is positive. The wave is traveling from left to right. For the for lambda 1, the wave is traveling from right to left, from right to left. So uh, the flux, that since in this numerical method there is a flux involved over here, maybe I show you the flux. This is the flux involved. So we need to look at the value, which value is entering from which flux, which phase. Two characteristics will be entering from I minus 1 half, and one wave will be entering from I plus 1 half. That's why we have I plus 1 half on the one side. Maybe I repeat this again for you so that you can understand that better. Qn plus 1, Qn minus delta T by delta X. Here we have fluxes. For example, we have I plus 1 half and we have I minus 1 half. These are the fluxes. What flux is entering from I plus 1 half? That flux will be the lambda 1. Delta T, delta X will come outside. So we have lambda 1. For I minus 1, we have 2 values. So we add these values. So this was the reason that in one formula we have three waves. This is the general formula. So it means that if we have 10 waves, for example, then you need to look at which wave is coming from I minus 1 half and which wave is entering from I plus 1 half at this I. So what is the contribution? Which wave has a contribution from which phase? If the two waves are coming from left to right, then you must add those waves, for in this case lambda 2, lambda 3. If the waves are traveling from right to left, then you must have a contribution from that wave, which is lambda 1, and these will be accommodated in the numerical method, which is the general numerical method. For example, if there is no wave entering from the right side, then we can neglect that, and we can just add, for example, minus, and this will become minus in that case. I hope you got the point. Remember that the W is the difference between two, Qi minus 1. It depends where we are calculating. If it is I minus 1 half, then we have I and I minus 1 half. If we have I plus 1 half, for example, then we had, for example, this is I plus 1 half. On the right, we have I, this is I plus 1. In that case, it will be, for example, Qi and Qi plus 1, or Qi plus 1 minus Qi, so on, right? So in general, that I was talking about the how we generalize this formula. So we have Qn plus 1i, then we have Qn I minus delta t by delta x. T is 1 to m. There are m waves. Some of these are positive. These are coming from left to right. These are moving from left to right. And also we have P is 1 to m. And these waves are, for example, lambda P negative and W P I plus 1 half. Okay. So the negative wave, the wave which has negative speed from right to left, these will be accommodated in this formula, and those with has positive, those have positive speeds, they will be accommodated over here. So that this is the final formula. Okay, remember that the positive here, the positive and this negative means that the speed which has positive or negative. This can be written as from our previous video, from previous lecture. It can be written as lambda 0, and then we have lambda minus, which has minimum of lambda and 0. Okay, let me just solve this for you for better understanding. Suppose lambda 2 and lambda 3 are greater than 0, and the value is, suppose that both has values 2. So lambda positive will be 2 comma 0 for wave number 2, and lambda 3 positive, that will be maximum. It also have 2 0. The maximum of this will be 2, and the maximum of 2 0 will be 2. When we have, for example, lambda 1, which has a negative speed, then we have minimum. For example, in that case, lambda 1 is minus 2. Minus 2, 0. The minimum of 0 and minus 2 is 0, and minus 2 is minus 2. So this will only survive. Okay, that's how we identify the waves. We can also generalize this whole thing. This can be generalized. For example, we can introduce a plus delta q I minus 1 half. That will be equal to p is equal to 1 to m lambda p plus wp I minus 1 half. Similarly, a negative will be delta q I plus 1 half. P is 1 to m lambda p negative. WP, since all the information is traveling from right to left, for negative waves, we should have WP I plus 1 half. This A plus means all the eigenvalues has positive speed, and A negative means all eigenvalues has negative speed. Delta Qi minus 1 half mean the difference between Qi and Qi minus 1. And for delta Qi plus 1 half, we have, for example, Qi plus 1 minus Qi. That's how we generalize it. So the general form is Qni plus 1, Qn plus 1i, Qn plus 1i, Qni minus delta t by delta x, a plus delta q I minus 1 half plus a negative delta q I plus 1 half. Maybe in next line, a negative delta Q I plus 1/2. That's how we write. You can see that there is a negative sign. I'm sorry, there is a positive sign. In the previous, this formulation, we already have for example, here we already have negative sign all the way in all the terms. But here, there is plus sign over here. What is the reason? The reason is when we have negative value, this negative value will be accommodated accordingly over here. So that will become minus, plus or minus, and this value can also be accommodated from delta Qi plus 1/2 and delta. When we solve that, all the terms over here, when a negative has lambda negative eigenvalues, when we put that value over here and we also solve delta Qi plus 1/2, we at the end get that formula Qni minus Qni minus 1 after putting the fluxes over here. You can maybe do the exercise. Just consider, for example, lambda 1, lambda 2, lambda 3 greater than 0, and take lambda 4 less than 0 and try to modify that numerical method and also get the W form, the waveform as well. So this was all about the waveform of Godunov's method. Remember that the waveform means that you need to write the fluxes in terms of W. W represent the waveform, and you may see that there are different waves hidden in these equations. So you have to write the waveform until over here. Okay. Thank you for watching.